We are going to talk about, in this session, about knowledge sharing, innovation, and translating research for the public good. And we're going to begin with Artie Rye, who is professor of law at Duke University and a nationally recognized authority on patent law, administrative law, and the biopharmaceutical industry. She has been engaged in discussions about knowledge sharing and innovation in the synthetic biology field for many years. She also has served as a peer reviewer for various National Academy of Sciences reports on intellectual property, and she is currently the chair of the Intellectual Property Committee of the Administrative Law Section of the American Bar Association. Professor Rye, we are very happy you could join us today.
Well, I'm really delighted to be here, and I want to thank the Commission for inviting me, because I think this is a really incredibly important inquiry. Perhaps I would, since I've been studying synthetic biology for a while, but just very excited to be here, and particularly excited to be on this panel about knowledge sharing and innovation for the public good. I think that's exactly the right way to frame the inquiry, because the relevant questions are not just about patents, much as I love patents, and formal intellectual property in the form of patents. They're broader than that. They're questions that involve how to set up the entire innovation ecosystem, as one might call it, so as to yield the most public benefit. So to get to one point immediately that has already been raised in several different contexts, the question of how the knowledge sharing and innovation questions in this area are different from or the same as knowledge sharing and innovation questions in other biological sciences. I think the way to think about it is as follows. Many of the questions are the same as in other biological sciences that have a very significant information technology component, because there are lots of biological sciences that are not so pervaded by information technology, but the various omics, the genomics, the proteomics, and so forth, have a significant information technology component. So we do have some precedent upon which to draw. That said, there are also differences, and I think one key difference from the standpoint of knowledge and information sharing is suggested by at least one definition of synthetic biology. As we've heard, there are multiple definitions, but I think this particular definition is very salient for thinking about knowledge and information sharing, and that is the definition that focuses on standardization. Some would say, I think Drew Andy among them, that standardization is the very essence of this field. That's how it differs from prior efforts in that prior to synthetic biology, there hadn't been attempts to rigorously and in a quantitatively predictable fashion come up with standardized DNA and RNA parts that could fit together into modules. That's very interesting, not only from a scientific standpoint, but also from the standpoint of innovation policy, and here's why. Standardization and the law and economics and public policy surrounding standardization is probably the most exciting innovation policy question that legal scholars and economic scholars are studying right now. The National Academies may actually launch a specific study on standardization in synthetic biology because it's so important. And that involves intellectual property issues, but it involves also other issues as well that I'll get into. So let me start by talking about some of the more conventional, and I say conventional in quotes because these aren't really conventional in any sense of being very old, we're talking about a few decades old in terms of some of the more conventional knowledge and information sharing and innovation issues raised by synthetic biology. These are also raised by sciences such as bioinformatics and, as I've suggested, the various omics. So for these biological sciences that have a very significant data component, data is obviously the coin of the realm. Per se, data is not protected by either patent or copyright. And unlike physical materials such as knockout mice or cell lines, which are also the coin of the realm for some biological sciences, data is easy to replicate and disseminate. There are no real costs involved in that. So one might imagine that we might see widespread data sharing in those biological sciences that have a very significant data component. Unfortunately, the available empirical evidence suggests this is far from the case. One major reason is just scientific competition. Outside of certain special large-scale genomic projects where NIH and other funders have mandated data sharing, very few scientists are sua sponte, want to engage in large-scale data dissemination, particularly prior to publication. And more importantly, perhaps even after publication, the available empirical evidence indicates that scientists are quite reluctant to share associated data that they believe they can use to extract additional publications. So there was a famous survey done by Eric Campbell and his colleagues at Harvard earlier in about 5 years ago, in which they found that almost half of all scientists who had asked for data associated with a published article, had been denied such a request in the last 3 years, almost half. So it's extraordinary, and the evidence from my colleagues at Duke suggests those numbers are only going up. So scientific competition is very, very significant and is a real impediment to data sharing. Now, commercial incentives may also play a role. Although data per se, as I mentioned, is not generally protectable by a patent or copyright, making data publicly available can result in the inability to secure patent protection. So perhaps not surprisingly, the same evidence by Eric Campbell and others, including some of my colleagues at Duke, indicates that association of scientists with commercial activity significantly correlates, even in various multivariate regressions, even after controlling for other factors, with refusal to share data post-publication. So these are real significant issues that are particularly important for areas like synthetic biology that are so heavily dependent on data. I've mentioned patents in the context of data sharing perhaps being something people don't want to do because it may result in the inability to seek patents. So let's go to patents directly. I think there's several potential concerns regarding patents. One set of concerns that has long been mooted in the patent literature relates to the possibility of broad patents on what one might call fundamental technological platforms. And there's some history in the history of science and technology of restrictive licensing of these broad patents, stymieing future innovation. Perhaps the most famous example is the Wright brothers patent on aircraft stabilization systems. That refusal to license on their part was really a major impediment to progress in the aircraft industry, and ultimately the U.S. government forced compulsory licensing of that patent, as did the U.S. government with respect to the AT&T transistor patent, which was an important component of integrated circuits. So there's some history of needing to have compulsory licensing in this area because there's been the owners of these patents have not licensed them in the manner that promotes technological progress the most quickly. Some patent landscaping research that I did several years ago that was published in the Texas Law Review indicates that we could be beginning to see some of these potential foundational patents in synthetic biology. Now, it's very hard to say that these are foundational patents because we're very early in the field, and often, as economists would say, ex ante, before the fact, you don't know what constitutes a foundational platform in a particular field. But in the article, I point to several patents, including one held actually by HHS, a broad patent that HHS holds on the combination of a nucleic acid binding protein and nucleic acid sequence for purposes of setting up any kind of data storage or almost any kind of basic Boolean algebra. So it's a very broad patent. It would cover a lot of what we've already seen today. Fortunately, it's held by HHS. It's not necessarily a problem. HHS is unlikely to assert it, and many of these patents that I mentioned in the Texas article, at least, are held by nonprofit entities and unlikely to be asserted. So perhaps more a potential indication that there could be issues with broad foundational patents in this area rather than any sort of immediate concern. Now, of course, even when there are patents, we could have enlightened owners, broad patents, enlightened owners licensing non-exclusively and broadly. And there's good economic theory to suggest you can do good and do well. In other words, you can make lots of money and also disseminate the technology widely, even if you do hold a broad patent on a foundational technology. So the Cohen-Boyer patent is a seminal example of a situation where Stanford and UC Berkeley made hundreds of millions of dollars, but also licensed their patent very broadly and non-exclusively. However, there is the concern, and economic theory does suggest that there are situations where it's economically rational not to license broadly and not exclusively. So that concern arises. And in some of the research I've done, there's some evidence that certain nonprofit players, at least Sangamo Biosciences being perhaps the most notable one, it has a wide array of patents on zinc finger proteins, which are a very important nucleic acid binding protein. They haven't always optimally licensed their technology. So there's that concern. Thus far, I've been assuming that these broad patents are valid. I just came back from a stint at the PTO, so I can say this, I think, with some authority, that although the PTO tries to do a very good job of making sure the patents at issues are valid, there's reason to believe in the information technology space, and these synthetic biology patents look more like information technology than they look like traditional biology. A lot of the patents are not of the best quality, and in particular, some patents at which I've looked are probably broader than the disclosure in the patent warrants. In other words, a patent is supposed to show the person having, quote unquote, reasonable skill in the art, or ordinary skill in the art, how to make and use the patent. These patents talk a lot about how to make, these are particularly Sangamo patents, talk a lot about how to make the optimal nucleic acid binding protein, but don't reveal the data set that would be necessary in order to do so. And various scientists with whom I've spoken say that this is analogous to having a software patent and basically just saying it's going to do X, but not revealing the source code. So there's inadequate disclosure in a lot of these patents, which is problematic to the extent that patents can be a very good thing for purposes of data sharing, because the patent bargain is supposed to be a bargain in which you get an exclusive right in exchange for disclosing to the world how you did what you did. And if these patents are not fulfilling that bargain, that's a real problem for the progress of science. And finally, we can have problems with patents that are associated with not just a few broad patents, but lots of patents, so-called patent thickets. This is a real problem in the information technology industries in particular, where thousands of patents, literally in some cases, can cover a particular printer or a microprocessor or what have you. And to the extent that, again, synthetic biology aims to be more like information technology and engineering in particular, we could imagine this happening, in theory at least. My colleague Bob Cook-Deegan at Duke has estimated there's something like 16,000 U.S. DNA sequence patents out there. So there's certainly a potential for these thickets, and he estimates about 48,000 genomics patents in general. Now, thus far, the empirical evidence indicates that genomics has avoided patent thicket situations for two reasons. First, academic researchers just ignore patents. They don't care. And they don't get sued, which is good from their standpoint, even though they could get sued because there's no research exemption for academic researchers. Just to be clear, all of you guys who are doing research and gals who are doing research could be sued if you're infringing patents. For the most part, it looks like you won't get sued and you don't care. So that's one thing. The second thing is, in the commercial sector, people do sue a lot. But in the commercial sector, these tens of thousands of patents that Bob Cook-Deegan and others have identified, oftentimes it's possible secretly to infringe those patents because you're infringing in the research context, but your ultimate product, your small molecule drug, doesn't infringe. So, and the statute of limitations for suing you runs out by the time people know you've infringed. So, the commercial sector, pharmaceutical companies do this. But the problem is that if we're going to have standardization in synthetic biology, standardization by definition is public. You can't have standardization that's secretly done because standardization means collective decision-making upon an agreed-upon standard. And so this is where I think the real concerns may lie in the future, because if we do achieve standardization on DNA parts or RNA parts of the sort that Drew Andy and others want to achieve, I think it's fair to say that those parts will read upon a lot of patents, and they probably do right now read upon a lot of patents. I don't know of anyone who's done a patent landscape of Drew Andy's of the MIT Registry of Standard Biological Parts, but I would suspect that they read on a lot of patents. Now, in the information technology industry, the way the that people have dealt with standardization and the reality of lots of patents on these standards is that they've set up these standard-setting organizations that get together and try to determine what the essential relevant patents are for the particular standard before they commit the industry to the standard. Because you can imagine that without doing that, if you committed the industry to a particular standard and somebody came along with a patent on that standard, they could extract a huge sum of money after the fact, after the industry is already locked into that standard, far beyond what that patent might be worth as one of 1,000 patents that reads on the standard. So the idea is for these SSOs, and they've been blessed by the Department of Justice in doing this, to get together and make sure that they license or commit the owners to license on so-called reasonable and non-discriminatory terms all of the essential patents. Unfortunately, this process has worked to some extent but doesn't work optimally, and so we have cases like one particularly famous case involving a company called Rambus that came in and was able to extract a huge sum of money on a patent it held, which it hadn't really disclosed to the standard-setting body it was involved in, which was coming up with a standard for random access memory, RAM. So this is it's potentially a really significant issue in synthetic biology that's different from other areas of biological science, even biological sciences that have a large IT component and haven't attempted to standardize in the way that synthetic biology has. So what are some possible options? Well, in the standards context in IT, there have been efforts, in some contexts at least, to either do these standard-setting organizations where you try to do ex-ante licensing of the relevant patents, or have alternatives that are either patent-free or where the relevant patent holders commit not to asserting their patents. So Linux, for example, is an open-source software system where most of the relevant patent holders have committed not to asserting their patents. So open source is one option, and that to some extent is what the MIT registry is trying, to the extent that it requires those who contribute parts to the registry to state that they won't assert their patents if they have any
I'm
patents.
going to ask you just to state the other options because of
Sure.
time.
Oh,
And
sure. Okay.
Otherwise, we simply won't have time for questions.
Okay. So open source is one option, sort of setting up an alternative relatively patent-free system. The SSO is the other option. So let me conclude by saying I've been sort of relatively negative about patents thus far. I do want to say make one very important point in favor of patents, and that is that I would be reluctant to have any sort of system where we try to eliminate patents in this area, because I think they provide some very, very important incentives. And the key is to manage them properly, not to eliminate them. So, for example, I'm quite concerned about the ACLU versus Myriad case, which will try to eliminate very broadly patents on genetic sequences. Thanks.
Thank you. Thank you. Ashley Stevens is currently Special Assistant to Boston University's Vice President of Research in the Office of Technology Development, and also Senior Research Associate at the university's Institute for Technology, Entrepreneurship, and Commercialization. He is a leader in the field of technology transfer and currently serves as President of the Association of University Technology Managers. Dr. Stevens has worked in academia and the biotechnology industry since 1982 and has been involved with both startup companies and academic organizations, helping to turn promising scientific ideas into useful products and companies. Welcome, Dr. Stevens. We're delighted to have you here.
Thank you, and thank you to the Commission for inviting me, and I, too, am going to skedaddle to the podium.
Oh, okay.
Okay.
Thank you. So as Dr. Gutman said, I have been involved in the biotechnology industry since 1982 when I moved to Boston. I've been with 2 biotechnology companies, and I've been involved with academic technology transfer for about 20 years now. So I really have lived through the growth of this industry. I've seen the transformation of Boston into a major center of biomedical research, largely based on the impact of spin-out companies from Harvard, MIT, BU, Tufts, and so forth. It's coincidental that I'm here with Jim, but I have been working with Jim Collins for many years in the commercialization of his synthetic biology technology and have greatly enjoyed that. Perhaps because of this history of mine in the biotechnology industry, when Valerie first called me to ask me to come and speak to you, my first reaction was, well, as I hear the debate on synthetic biology, I'm hearing the same issues that have been discussed, back in the late 70s and early 80s, and I think others have said that here today. And so what I'm going to do is take you through how some of these issues have been managed over time. So I'm going to talk a little bit about the Association of University Technology Managers, make a couple of comments on the patent system, talk about patents and their impact on scientific research, and then talk about intellectual property in the biotechnology industry and the impacts of patents on scientific research, and then 1 or 2 specific thoughts about synthetic biology. And then I know I will not have time to get to them. I have some data and statistics at the end of my presentation you might find interesting on technology transfer in the U.S. So Autumn is the leading association representing technology transfer professionals globally. It's been around for about 30 years. We have 3,500 members in 35 countries. Our primary activities are professional development, educating practitioners. We provide services to mentors, in particular, a great deal of data collection. We are the definitive source of data on technology transfer, and then we do advocacy. So first, let me talk a little bit about the patent system. I think the point I want to make is that the patent system is continually in flux. It wasn't until Microsoft was 5 years old that you could first get a patent on a piece of software through the Diamond versus Deere case at the Supreme Court. In 1982, we established the Court of Appeals of the Federal Circuit, which had a tremendous impact on strengthening the value of patents. Through the 1980s, 3 landmark cases made biotechnology patentable. Chakrabarty establishing the patentability of microorganisms, In re Hibbert on sexually reproduced plants, and then the famous Harvard mouse patent on genetically engineered animals. And then a decade later, we had the State Street Bank decision confirming the patentability of business methods. So I would say through the 80s and the 90s, we had a strengthening of the patent system. And then recently, the Supreme Court has started to get back involved with the patent system in a big way. It had largely stepped back after the establishment of CAFC. And we've had a number of cases which have redefined, I would say have limited the scope of patentability, and certainly have reduced the economic impact of the patent system. For instance, eBay versus Merck, the right to an injunction, that came out in, I think, May the 26th, 2006. About 10 weeks after BlackBerry had paid $615 million to be allowed to stay operating. And I think most people think that if BlackBerry had been able to keep it off till after eBay versus Merck exchange, they'd have saved about 500 to 550 million of the $615 million. So the patent system is continually changing. Let me give you one particular example of how this impacts on scientific research. There were 3 patents filed all around the 2000 time period, which attempted to claim all downstream drugs that modulated newly discovered biological targets. 2 of these were from academic institutions, the University of Rochester, Harvard, MIT, and the Whitehead license to Ariad, and 1 was from Pfizer, a drug company. So these inhibited COX-2, the superaspirins. Pfizer's was on the application of all inhibitors of PDE5 to treat male erectile dysfunction. And then the Ariad Harvard case was NF-kappa B, a key modulator of the inflammatory system. These all claimed these targets through a method of treating people with certain disorders by modulating those targets. All 3 over the next decade have been ruled invalid for either enablement or written description. So I think this is an example of how sometimes overreaching patents might get issued, but then when challenged, do get shut down. Let me talk a little bit now about patents and scientific research. The U.S. technology transfer system has really been in place robustly for about 30 years since the Bayh-Dole Act of 1980, which allowed universities to freely elect title to the result of federally funded research, obliged them to share the proceeds with the inventors, gave them pretty much complete discretion on licensing terms, required U.S. manufacture of products sold in the U.S., a preference for small business, and a non-exclusive license to the U.S. government for its own use, and retained the ability to grant a compulsory license in the public interest, which has been invoked rarely, and there is currently a new invocation in play over the last couple of months. If we look at the traditional scientific paradigm, our ivory tower scientist does his scientific research, publishes a paper, and then gives presentations on those papers at learned society meetings. And I think what the new scientific paradigm is that in parallel with this, we have added a string whereby simultaneously with the publication, and hopefully before it, we apply for a patent application, and then that patent application is used to create relationships with industry to take those inventions and to develop them. And there has been involved a concept called the patent paper pair. Try saying that 3 times quickly before a presidential commission. Created by Fiona Murray at MIT. She looked at 50 papers in Nature Biotechnology over a 3-year period, found 50% of them had a corresponding patent. A more recent study, which looked at more broad-based journals rather than Nature Biotechnology, which perhaps inherently selects for science of commercial relevance, found a third of papers in biotechnology in a 6-month period in Science and Nature had a corresponding patent. So clearly the scientific community has embraced this parallelism of scientific research and then creating the tools to be able to engage with the commercial sector to commercialize. How the extent of faculty participation in this is data from the Thursbys at Georgia Tech. People like Jim Collins are in a small minority of faculty. About 2/3 of faculty never engage in the process in their entire career, and the rest is a spectrum in between. So why do we have patents? As Ardi said, and I won't reiterate this, they are legally sanctioned monopolies to promote disclosure by inventors of their discoveries, and then they strike a deal with the government in which they disclose and in return get a 20-year monopoly on their use to allow the attraction of investment to develop the technology. Now, a patent, you have to remember, is exclusionary, not permissive. They let you build a fence around what you have. They don't necessarily allow you to practice what you have in your own invention because there may be broader patents that encompass what you have done. What they do allow you to do is to stop others practicing your invention without your permission, which is what we call a license. As Ardi said, you are under no obligation to grant that license. You can keep the whole field to yourself, but they give you control over the development of the technology. So let's look a little bit at intellectual property in the biotechnology industry. I would posit that the intellectual property in biotechnology is profoundly different from that in the traditional pharmaceutical industry. A small molecule drug typically has 2 or sometimes 3 layers of patent protection. You can see this in the FDA's Orange Book, where manufacturers have to list the patents that protect their drugs. There is always, or usually, a composition of matter. There's generally methods of treating specific indications, and then there may be a formulation patent. You may see a billion-dollar drug protected by 1 or 2 patents alone. Biotechnology, however, is characterized by many core discoveries being made and patented in academia, and by the existence of platform technologies that translate specific genes and protein discoveries into marketable products. And there is intense licensing activity in the biotechnology industry, and products do carry substantial royalty burdens. So let's say you've discovered a composition of matter of a gene and a protein and you apply for a patent. But if you wanted to just use it to use as a screening patent, you didn't need a license to Cohen-Boyer before that expired. If you want to use it therapeutically, you need a protein expression system. If you want to use it in gene therapy, you need a delivery vector. If you wanted an RNAi, then you need access to the Tuschl and the Craig Mello Fire patents. When you look at the biotechnology industry, there have been numerous patent technology platforms that have been owned by universities. I list some of them here. Artie already mentioned Cohen-Boyer, but we have Riggs Itakura, which was key to bacterial production of DNA, and then we had Axel, key to mammalian cell production of DNA, the Kabili patents on monoclonal antibodies, the Thomson stem cell patents, the Tuschl-Bellow-Fire RNAi patents. There have also been substantial technology platforms that have been owned by companies. The Kabili patents were actually done by Kabili at City of Hope, but Genentech had control of them and did the licensing. We had the Mullis patents at CETUS on PCR, the Queen patents at Protein Design Labs on the humanization of monoclonal antibodies, and the Ladner patents on phage display owned by Dyax. These have been licensed, and licensing is a very, very fine-tuned weapon. You can do highly nuanced license agreements and transfer infinite degrees of scope of rights to these patents. So why do people license their technologies? Either because they can't or won't develop a technology. A university, it's not part of our mission to develop technologies and sell products. A small company may have inadequate resources to take the product to market. The invention may not be sufficient to market a product itself, as maybe one of these platform technologies that needs additional inventions to productize it. So you do a deal where somebody takes the majority of the risk and returns the majority of the return, and the investor receives, an inventor receives a small part of the return. In other words, 5 or 10 or 25% of a big pie is going to be worth more than 100% of a small pie. And licensing platform technologies has been highly profitable. Genentech, $250 million from Kabili in 2007 alone. Protein Design Labs, a similar number from the Queen antibody patents in 2008. Cohen-Boyer made $254 million for Stanford and the University of California, San Francisco over its lifetime. City of Hope got a $500 million jury award against Genentech just for Riggs Itakura. Axel made Columbia $800 million over its lifetime. I think one of the other questions that I discussed with Valerie was the issue of do patents inhibit research? Certainly, as Artie alluded to, a lawsuit, Maddie versus Duke, did establish that universities are in the business of doing research and that patents must be respected. However, infringement suits are highly expensive, probably a minimum of $5 million, and there is rarely sufficient economic value in basic research to justify enforcement actions, so I agree with Artie giving you the measure of comfort that she did in her remarks. Another thing to remember is that only issued patents can be enforced, and cutting-edge research builds on prior work, which takes place well before patents can be issued. And we have robust material transfer systems in place. The Universal Biomaterial Transfer Agreement Treaty has over 300 signatories now. And academic institutions license their patents with explicit disclaimers concerning blotted patents. We leave ensuring freedom to operate entirely to our licensees. There has been overreaching use of patents. There have been attempts to use patents on research tools overly broadly, to reach through and claim rights to discoveries made using these tools. One thinks of the Harvard mouse and the Crelox patents in this respect. But I want to point out to you that these were all made by, these assertions were made by companies. One company, actually, seemed to be a slow learner, not academic institutions. Another issue that's raised is, do patents encourage secrecy? Well, this is, I think, a big misunderstanding. Patents require complete disclosure of the best-known way of practicing the art as of the date of filing. That's what we call best mode. Patents are another form of publication. We've had examples where professors file patents, couldn't get the paper accepted, but the patent was their ultimate claim to priority. U.S. patent applications have been published after 18 months of filing since 2001. And as somebody has alluded to, scientists are secretive about the interim results of their research until they reach a publishable conclusion. In 1993, I had the privilege of working with Richard Kolodner, who was pretty sure he was on to the discovery of the hereditary colon cancer gene. And his challenge was to get the materials to prove that fact without alerting a certain researcher further south of what he had found. And the race was on, the word leaked out, and we managed to beat that guy by only 2 weeks. So until things are publishable, scientists are very protective of their discoveries. And availability of provisional patent applications since 1995 has facilitated patenting without delaying publication. So if I can take one more minute, I want to ask the question, is there anything fundamentally different about the intellectual property aspects of synthetic biology? Some is certainly being developed in the private sector, private foundations such as Ventnor. Some is being delivered in academia, such as the University of Wisconsin's recent patent application on the reduced gene set E. coli, which I think will have probably more commercial relevance than Ventor's mycoplasma. I think the scope of what is patentable subject matter will be determined by the Patent Office and the courts, and I think we should have confidence in the robustness of those processes. And I do want to leave you with the thought that the intellectual property regime, I believe, is sufficiently robust to handle the challenges. Artie did talk a little bit about standard setting. There's been little in the way of standards and patent pools in biotechnology, but very interestingly, MPEG-LA, which is the original independent patent pool operator and standard setter, has recently announced a patent pool on gene patents, genetic testing patents, which I think is a very interesting development in the expansion of novel mechanisms for intellectual property management. Thank you
very much. Thank you. We are now on to our third presenter, and he is David Weiner. Am I pronouncing that correct?
Weiner.
Weiner.
Okay.
I knew there were two options, and I had a 50-50 chance I got it wrong. David Weiner is a professor of pathology and laboratory science at the University of Pennsylvania. He is a world-renowned leader in immunology as well as in gene vaccines and therapy. His laboratory helped to found the field of DNA vaccines. He's the recipient of numerous NIH grants. I take it that's by way of some disclosure, but it's good disclosure. An advisor to both the FDA and the NIH, and a key player in many startup biotechnology companies. He currently serves as chairman of the scientific advisory board of Inovio Pharmaceuticals. Welcome.
I'm also going to use the podium.
Good. Welcome up to the podium. Yes.
Well, I greatly appreciate the invitation to be here. I thank the panel for allowing me to come and speak with you, and it's an honor to follow such distinguished individuals who actually know something about what they're talking about. I'm from Brooklyn, and really my background in any of this is questionable, as my three daughters often tell me. So I'll share with you some thoughts. When Valerie called and asked me to participate, she asked me if I could talk a little bit about my experiences based on a basic researcher who's interacted with different branches of the government as well as industry on some of my possible background relevance. So the points for discussion I sort of summarized up here. So my first point is one that several speakers have already brought up. I don't believe that synthetic biology, as pointed out, is new. It's really an extension of molecular biology and biotechnology. And the Ventnor paper of cloning a 1 million base pair genome sequence into a microbe is an achievement because it's synthetic, completely synthetic, but it is the natural organism sequence. And it actually had to be specifically labeled for them to tell the difference between that sequence and the native microbe sequence. So in many ways, previously we've engineered bacteria, viruses, and animals, and we actually performed the sequencing of the Human Genome Project with much larger pieces of synthetic material than this. And there is a system in place that I would argue has been a highly successful engine for including oversight and safety of developing new drugs, diagnostic, agricultural, food safety products, job creation, and significant value for the American public. I'd also like to highlight that current drug development costs approximately for a therapeutic at least $1 billion on average or more, and take 10 to 15 or more years to accomplish. In fact, vaccines take longer than this, and that's an important issue when we talk about patents. And there are safe harbor provisions that protect developers during the active patent period in order to allow them to compete once the patent has expired. And therefore, patent effect is relatively limited in many senses for new therapeutic development. I'll go into that a little more on following slides. If a company cannot be allowed to have levels of patent protection, and I particularly enjoyed the last two presentations that talked about limitations of patents, then this will not serve the American public, as drug development cannot be supported by industry. Without a patent, no large pharma is going to consider investing $1 billion to go forward. They have to feel they have ownership of something, and we have to enable them to do that. And this, of course, serves America in many ways with products, jobs, and it's very important in U.S. competitiveness. Just because we make this change, the rest of the world might not make this change, and we have no control over that. Industry is currently under a great deal of pressure, both biotech and pharma, and industry supportive measures and further enhancing incentives, I think, is particularly important at this time. And this commission dealing with these type of issues, I think you're stepping exactly into that realm as well. So my own personal background is in the area of DNA vaccines. I want to point out these are actually synthetic vaccines. And therefore, I never really considered them the same way we talked about today, but it is an area of completely synthetic, computer-designed gene sequences from pathogens that can be delivered as pure DNA sequences. And the scientific advantages of that are, again, when we try to engineer something, we try to improve safety and effectiveness. And so it's the safety of a non-live with the effectiveness of live vaccines. And there's lots of advantages to that. And this is an example of the synthetic delivery into an animal model, and this green is the expression of that gene in a living animal. And actually, these vaccines have gone into 10,000 at least humans already by different groups and companies. And so we have a lot of experience with this as far as safety in people. So synthetic biology allows the rapid construction of nucleic acid sequences in a laboratory and can be used to transform cells, engineer them, create safer and new organismal phenotypes. And the recent Ventnor work increases the size of the synthetic sequences, but this can be argued. Bacterial chromosomes are actually very large pieces. Yaks are extremely enormous pieces. And in fact, if I just took an example from someone on our panel, Colonel Michaels, who led the HIV vaccine program that showed us the first possible signature of an effective HIV vaccine of 30% in humans, they used a recombinant poxvirus system that actually encodes a genome of 10 to the 8th base pairs, 100-fold larger than what we're talking about Craig Venter's work. That was put into tens of thousands of people with as I understand, a very excellent safety record. And so there's really been this type of manipulation going on. In fact, in humans, for considerable periods of time, the poxvirus field started in 1982 publicly, I believe. So synthetic biology is a continuation of the evolution of molecular biology. And we have been engineering for years recombinant viruses, bacteria, vaccines. Yeast recombinance is an entire field of recombinant vaccines, and many of these have been in humans for considerable periods of time. And we've been generating new phenotypes for decades. And synthetic gene sequences are in routine use in laboratories and in animal products and in the clinic for some time. And I might point out that we tend to overestimate our own power here. Nature is by far dramatically superior to anything we're doing. I'm pointing out, I have an example here of two different inbred dog species, and these are all derived from the wolf. If we talk about cows, cows now can produce liters and liters of milk. They can't do that naturally. We have chickens that have breasts larger than the entire rest of their bodies, and all of this is done by a reassortment and breeding of tens of thousands of genes naturally by mating. If we talk about in the natural world, malaria, for example, is delivery of hundreds or thousands of different genes from a single parasite into our body. So nature really has the upper hand here, and we're still playing with just a few gene sequences. Oversight is clearly important, and for many years, since, as I'm arguing here, it's not very new, there's been a lot of discussion in the U.S. Of safety and how to move forward in people, animals, laboratory studies, plants. And I also want to point out this is a worldwide issue, and really that's a significant importance now. And we need to, of course, continue to watch this in all important areas of science for developments that present unique issues. So some broad strokes on patent and biotechnology, which certainly the last two speakers are much more capable of addressing than myself. Academics and non-profits have the ability to basic research in patent areas, as was discussed. And the human genome, I want to point out, has been sequenced and all open reading frames have been identified. And this is about research from about 10 years ago. And Human Genome Sciences, of course, cloned all the open reading frames from messages about the same time. So most of those are not new issues, therefore. New research may uncover forms of genes that are particularly associated with disease, but these may take years or decades of work, and then a patent around this specific application, the way we use it, is, of course, seeming worthwhile. The average new therapeutic drug will take more than 10 years to develop. Vaccines, much longer. HIV, the quest has been more than 25 years. Polio vaccine took more than 40 years. For example, flu took also a similar amount of time after validation of particular gene targets. So if a patent is filed, there'll be about 3 to 5 years of research, and then maybe industry will jump in. This is not changed dramatically by synthetic biology. And so if you put these numbers together, you can see that they're not going to the patents do not dramatically impact therapeutic development in a negative fashion. In fact, they're enabling. They give industry a way to move forward, to allow them to bet large amounts of money and resources, and they create jobs. Companies that embark on product development are protected by safe harbor provisions. The safe harbor provisions extend beyond mere research and development of drug equivalents to include basic experimental research on new drug candidates and other products that require regulatory approval. And as stated above, therefore, these have a clear effect, but a limited effect on ultimate therapeutic development. So the major points are, companies cannot justify the hundreds of millions of dollars in investment necessary to undertake a new therapy or vaccine development without being able to establish patent ownership position with their management. Otherwise, what are they working on? In biotechnology worldwide pursuit, we do not control patenting in other countries. Further curtailing U.S. patents in this area will likely put U.S. at a competitive disadvantage. And so I list here some of the positive impact of all this patenting in biotech. Some are very obvious. Over the last 30 years, lifespan in the U.S. has increased an average of 2.2 months per year. We're sort of the first generation ever to almost be guaranteed to see our grandchildren. That was not true of the generation that fought World War II, for example. These are enormous benefits. There are more than 200 biologic medicines and vaccines that benefit millions worldwide. There are an additional at least 1,200 biotech diagnostic tests being used in clinics around the world. We live longer, more active lives. There's many advances, eyesight, hearing, autoimmune disease, cancer treatment, and Viagra allows individuals a sense of, well, you can fill in the rest of that yourself. It is perhaps the most active area in the pharmaceutical industry. More than 600 new drugs for Alzheimer's, cancer, autoimmune disease, and many, many, many other heart disease in development currently. The current system, including regulation, created hundreds of thousands of jobs, direct plus more indirect, as typically bio reviews claim that we get 2 for 1 out of the 2 for 1 jobs from the outside community from the inside job. And these jobs are very high paying, so this is particularly important. Increased investment by the private sector has really been spawned by these patents. Development of hundreds of billions of dollars improves food safety, and in fact this leverages the initial NIH public funds. So if we think that the actual cost of developing a drug is about $1 billion and NIH seeds 5 or 10 labs to do research at a few million, you can see that the leverage here is enormous, an enormous benefit to the American public. And examples are very straightforward. HIV was a death sentence in 1990. Now in the U.S., it's more of a chronic disease. Breast cancer survival has dramatically improved. We can go through many other lists. There's new vaccines that didn't exist. The HPV vaccines are threatening to wipe out wonderfully, this cervical cancer, which are tremendous accomplishments. And we can go on and on with the autoimmune disease drugs, for example. Clearly, this is an extremely important and valuable area for the United States. But current economic conditions are significantly problematic. The biotechnology industry is under tremendous economic pressure. Raising capital is difficult for a variety of reasons. The large pharma situation is scary and difficult. Consolidation, just consider this, that in the last few years we've gone from 17 major pharmaceutical companies to just down to 11. Think of the loss of jobs, because when they consolidate, they don't stay the same size. They usually shrink down to the exact size they were before. This limits research outlets for academic and NIH research, small biotechs, and it limits the number of new drug programs. It's estimated somewhere between 50 and 100 programs are lost during these mergers per company. So think of what a loss that is to the American public. If you talk about vaccine manufacture, the situation is even more dire in my estimation. In the 1980s, there were 27 considered large U.S. vaccine companies in the 1980s. Today, we just have 2, Pfizer and Merck. We don't even have a large company that makes the influenza vaccine that we were so concerned about last year. And we have a relatively limited license to MedImmune for that flu vaccine that doesn't cover all age groups. It's important to continue to allow reasonable protection and further incentivize and enhance U.S. competitiveness in this area. So, my final thoughts are, in place as an example of a highly effective government-regulated system that engages the private sector to leverage public investment, which has resulted in the creation of new therapeutics, diagnostics, agricultural products, biosafety products, and these have significantly enhanced the quality and quantity of American lives. With an excellent record of safety, it continues to provide a significant job engine for creation and drives billions in private investment to an area of value for U.S. citizens. Current systems, including patent protection, limited scope of patent allowance, safe harbor provisions, long drug development timelines provide incentives and stability and allow for continued new therapeutic development, which is important for the U.S. economy. Elimination or further limitation of patent protection in the area has a high probability to eliminate much industry incentive, which would lower the U.S. competitiveness because we would be the ones doing that, not our competitors. Due to significant economic pressure in the biotech and pharmaceutical industries, additional incentives are particularly important. So I'll stop there, and I thank you very much for allowing me to present today.
Thank you very much. Let's thank our 3 presenters. Yeah. So we have much food for thought here about the way in which patenting affects the public good. Anita Allen, since you are one of our certified law professors, would you lead off with a question?
Thank you. I think what we heard just now is a very pro-patent perspective from Dr. Weiner and a somewhat skeptical but also pro-patent perspective from Professor Rye. Artie, you were very helpful in pointing out some of the problems, but you did in the end say that you think we should not eliminate patents but should rather manage them. And then we also heard a very optimistic point of view from Professor Stevens. So Mr. Stevens, no one's saying let's not patent or let's be extremely cautious in patenting. Instead, I think we're hearing let's figure out how to capitalize on our already robust patent system, and then let's also try to manage. So my question is really going to be mainly directed at Artie Rye, which is about, well, how do we manage? I mean, so if the system is as robust as Stephen says, and as wonderful as Weiner says, but you think we should be managing the system, what specific things would you have us do to make sure that we can benefit from the patent system in the ways that were described, but not harm issues of access and justice that I think you have in mind when you express your skeptical cautions?
Right. So I think that in terms of management, there are 2 primary mechanisms. One is the grant of the patent has to be over valid territory. In other words, we should make sure that the patents granted by the PTO are high quality. And I fear, unfortunately, that in general in the biological sciences, they have been of high quality according to the standards of the patent system, the internal standards of the patent system. But as we get more and more into fields where the biological sciences resemble information technology, things get a little more dicey. There's a lot of complaint in the information technology industries, basically Silicon Valley, about the quality of the patents issued in the IT industries regarding covering software patents, telecommunications patents. Lots of momentum for that reason, or at least there was some momentum for that reason, to have significant patent reform particularly by those industries. So that's one thing. So that's high quality. Then the other set of kind of mechanisms that have to be emphasized, and maybe this is even more the remit of this particular committee, because high-quality patents, presumably the Patent Office should try to be, and I think they are. Dave Kapos, the head of the Patent Office, is trying very hard to do that, is thinking about licensing. And there are many different actors in the licensing landscape. There are universities, and universities need to manage their intellectual property in the public interest. And I think for the most part they've done a pretty good job. But I think everyone recognizes that there are situations where universities have perhaps exclusively licensed in situations where they shouldn't have exclusively licensed. This is not synthetic biology, but in the case of diagnostic patents, which is what's happening in the ACLU versus Myriad case, the breast cancer gene patent case, I see that mostly as a problem of bad licensing on the part of certain public sector institutions, exclusive licenses where they didn't have to be exclusive licenses. So we have to be vigilant about that set of issues. We have to be also vigilant if and when we get standardization, and I'm not sure we will. That's the hope, that we'll get standardization. Really look up at what the IT sector did correctly in terms of setting up standard-setting organizations and patent pooling, but also where those mechanisms have not worked perfectly, where there have been situations of hold-up. And I think on the whole there haven't been that many, but there's a lot going on in the IT sector in general in terms of thinking about how to make those mechanisms work better. And I think if we get standardization in synthetic biology, that thinking should translate directly into.
If I could just ask you a couple of quick follow-ups. And one is there any reason to think that the products of synthetic biology should be not patented? I mean, issues analogous to the ones we visited with business methods or animals and so forth. That's sort of one. I think a lot of people have anxiety about maybe we're going to be creating a life form and then slapping a legal protection, which is inappropriate somehow for the kind of thing that it is. And the other thing is, you do think that we should manage, but who is the we? Who is that? And that's really a very important question. Who is the we? Is it the government? If so, what part of government? Is it some kind of private sector management that ought to be going on, especially when it comes to sort of the norms of licensing and so forth?
Yes, I think it's a little bit of both. I think the government does have a role to play, and including this commission has a role to play in setting up norm expectations for licensing, for example. And I know this is going to be a question that's discussed in the context of the biosecurity panel. There's, for example, this is not exactly IP per se, but it could have relevance for IP considerations as well. I take it there's going to be some decision reached in the not too distant future about a standard for screening gene sequence orders. And there I think the government, for example, has a large role to play in making sure that's the appropriate standard. It's appropriately rigorous, and I suspect that tomorrow perhaps we'll have a discussion about whether the government's approach has been appropriately rigorous. So definitely the government has a role to play. And also in modeling best practices with its own licensing. So HHS, I mentioned HHS's patent, which it hasn't asserted, thankfully, because I think that's not the sort of patent that should be asserted. So the government can model best practices with respect to non-assertion and also with respect to licensing. Because the NIH has, in particular, for purposes of synthetic biology, already has a significant patent portfolio and is likely to accumulate more patents. And then so I think it's a dynamic interaction between the government and the private sector. In general, I'm not a huge believer in very stringent top-down regulation. I think norm setting is probably the better way to go.
If I can make a couple of comments.
Yeah, and excuse me for this interlude. If anybody in the audience wants to ask a question or make a comment, please come up to the microphone, okay?
Yeah, I want to reiterate that I think we should avoid the temptation to meddle with the patent system. That takes an extraordinarily long period of time. Typically, the U.S. Congress has been trying to reform the U.S. patent system for 6 years, and it still seems to be stuck. International treaties take typically 8 years from signing to implementation, and whereas licensing behavior can be changed much more quickly. I would remind the panel that in 2001, with the conclusion of the Human Genome Project in sight, President Clinton and Prime Minister Blair made a 201-word statement that they were going to stop patenting of the human genome. And this led to a secular decline in the finances of the biotechnology industry that probably has still not been reversed today, even though they backtracked very quickly in what they had meant by that statement. Now, Adi did talk about standard setting, and this has been one of the roles that Autumn has been active in recently. About 6 years ago, we established the 9 points to consider when doing licenses, which talk about some of the things you should look at when coming to a license agreement. A year ago, we set a statement of principles and guidelines on how to include protections for global health when licensing healthcare inventions. We are currently working with the Bioindustry Organization on a set of guidelines for licensing genetic tests, because this is a subject of some controversy lately. I do want to make one comment, and that is it is very dangerous to exercise hind vision. One could criticize the University of Utah for exclusively licensing the BRCA1 and BRCA2 genes to Myriad in 1995. They did it because they thought it would lead to a more robust and better breast cancer gene. I actually started the work that led to the cloning of those genes. When I decided to license the hereditary colon cancer genes non-exclusively, I did it because I wanted to get the maximum commercial impact, because I wanted every offer of tests to come up with, to be able to offer our test. So looking forward 15 years, I'm probably considered to have come to the right conclusion, but for the wrong reason. And the University of Utah is considered to have come to the wrong conclusion, but for the right reason. It is very easy to look back and be smart.
Now, because we haven't yet engineered eyes behind your head, I just want to say there is a line now of we're very welcome of people, not you, but Ashley. So I'll ask the presenters to swivel, and let's take questions. Yes. And introduce yourself. Just say your name and where you're from.
I'm Al Giovanella from the University of Pennsylvania. And with drugs, there's, in a lot of other countries, there's virtually little or no patent protection, and it makes things uncompetitive for us here. And I was wondering, is it reasonable to assume that for genes and for these, for the synthetic microorganisms, that patent protection will be about the same as drugs? It'll vary greatly, and it might not have, in some countries you might not have very little protection. So.
Yeah, thank you.
Well, I've been looking at this issue in the context of genes specifically, just because the ACLU versus Myriad case raises the question of the patentability of genes. And actually, interestingly, with the salient exception of certain developing countries like Brazil, most other countries have fairly robust patent protection for genes. With respect to the products of synthetic biology, well, I mean, one of the things that's interesting with synthetic biology is that it's not just pharmaceuticals and medical products. There'll be lots of other types of products that will be produced. But my guess is that unless, court decisions cut back patentable subject matter significantly, we in the U.S. and for the most part abroad will have fairly robust protection.
Thank you.
There are nuanced differences between patent systems. You can't get a method of treating patent in Europe, for instance. The different timing rules can sometimes result in different groups winning the prize. But I think in the developed world, then by and large, there will be comparable scope.
Thank you.
Ellen Batesel,
Yes.
Los Angeles. My question is more to the standardization on the international front, because I understand we're seeing a lot more development abroad to avoid the problems and the expenses that we're experiencing here.
You know what I'm going to do? I'm going to take the next question as well, and that way you all can look, you can use your microphones more easily. Yes, so standardization on the international front, yes.
This isn't a question. Answer her. This isn't a question. This is a comment left over from the last meeting.
Please introduce yourself. No, you can make a comment.
Okay. I guess you could consider this a temporary recess. My comment has nothing to do with synthetic biology. This is left over from the last meeting. They ran out of time. This concerns rather leftover matters, bioethical matters, which were significantly evaluated and acted upon, but which have not yet been completed, and with cruel and inhumane consequences. I'm here to urge you, Commission, to put on your agenda for a very near future meeting the subject of the need to restart and complete a government-wide federal policy change to protect citizens for the very first time from non-consensual U.S. classified human research experimentation. President Clinton, in March 1997, ordered a government-wide federal policy change to accomplish that, but that policy change was not completed before he left office. President Clinton ordered this policy change after the Federal Advisory Committee on Human Radiation Experiments. You had Dr. Fadden here. She was chairman of that. They recommended that such protection was truly needed. Specifically, in their final report of October 1995, Recommendation 15A, that advisory committee recommended the adoption of a federal policy requiring the informed consent of all human subjects of classified research, and that this requirement not be subject to exemption or waiver. The Bush administration took no known action upon the matter, neither to cancel nor to examine nor complete this important policy change. Wouldn't you want to live in a country where specific federal regulations or laws protect citizens from non-consensual military, intelligence, or other classified human research experimentation, secretive testing on humans? Yes, no? But this is not a hypothetical problem. And that's why I'm here. Our U.S. government today is conducting non-consensual experiments. Most notorious among ongoing non-consensual U.S. classified human research experimentation by U.S. government is ongoing research, development, testing, and evaluation of real-time electromagnetic signals, monitoring, and assault of the human body and brain day and night, typically for years and years, with no apparent end in sight upon each non-consenting innocent U.S. citizen. There are at least 300, 500, or probably more innocent U.S. citizens targeted by this ongoing program. In some cases, the victims are also targeted by reported low-tech harassment. Among the victims these days are now more numerous females and males in their most regular childbearing years. Due to this crime, hundreds of innocent citizens are being denied their day-to-day liberty, their careers, their preferred education, and for many, the human right to found a family. As you know, your Commission's purview includes bioethical issues related to advancements in science and technology, neuroscience applications, this involves that, and the protection of human research participants. Please realize that the Office of Human Research Protections in HHS is not currently an appropriate forum for this matter because that office only regulates HHS-related experimentation research. Even though OHRP, part of HHS, was designated by President Clinton as the lead agency in coordinating the joint rulemaking when he ordered it originally. Today, in 2010, the rulemaking apparently needs to be ordered as restarted by President Obama. Therefore, your Commission is the most appropriate and specific forum for this issue. Thank you.
Thank you. We'll accept that as a public comment, and you should feel free to submit the entire text to us.
You have that text from the prior meeting.
Okay. Thank you. Thank you for that. Let's go back to the international and standardization question. I don't know who would like to take a stab at that.
Well, I wanted to clarify what the question was referring to. Are you talking about...
Can I just, while we're addressing standardization, I have a question on that, so if you could just build on it.
Sure.
So, Artie, you mentioned that one of the goals of synthetic biology is to move towards standardization, and that this has implications for how we think about patents and the application to the system. If you could elaborate in your answer to this as well, in what ways you think it'll make this unique relative to other fields of genetic sequencing, and how standardization, if we do ultimately end up in that direction, how we should be thinking about it differently for standardization purposes.
And Artie, just you don't feel you have to keep turning. Just use the microphone, then everyone can hear you. Okay. Thank you.
Well, I did want to get some clarification on the international piece, though, because I wasn't entirely clear on. Are we talking about a situation? I mean, there are a couple of different international pieces to the standardization puzzle. One is the question of whether research gets moved offshore because particular implementation of particular research would infringe upon patents in the U.S. And there's some evidence of that. Wes Cohen has...
I think she has. Do you want to clarify?
Well, we know that it does.
Yeah.
I mean, I'm an attorney, and we finance deals out in L.A., and we move them to China.
Right.
And that's it. We move them to India. It's cheaper. And then we have the issues that come with maybe a misunderstanding or a deliberate misunderstanding or an inadvertent misunderstanding on standardization. So that has its own implications. So I'm asking you to address that because we started the meeting with an international perspective, and I'm seeing it go provincial.
Right. So, I mean, there is evidence of offshoring in order to avoid patents, which does suggest that not all entities, even in the biopharmaceutical sector, think our current level of patenting in the U.S. is optimal for their purposes, but that may or may not mean that we should reduce the current level of patenting. In terms of, and you guys should feel free to expand on that as well. In terms of, Nita, your point, I mean, it's really hard to say because the technology is so inchoate right now exactly how all of the issues in the IT sector with respect to standards are going to, or if at all, have an impact in synthetic biology. But at least looking very cursorily, for example, at the Registry of Standard Biological Parts, there's every reason to believe that reads upon thousands of patents. And I don't state that I don't want to state a legal opinion, but I think that's probably the case. And given that that's an academic inquiry right now, I don't think that's a problem at all. But if that type of standardization was to be agreed upon by commercial companies, so everyone knew that they were implementing those standards, that's when you get the potential, as has happened in the IT industry, for major lawsuits. And that's what we're seeing in IT.
Because the standard products infringe on other patents that already exist? Or
Yeah,
okay.
Exactly.
Yeah. Yes.
Tim Trevan from the International Council for the Life Sciences. This doesn't deal with the patent side of the international management of this field, but I don't know if now is the right time to report on this or whether in the biosecurity and biosafety session, but there are two efforts at standardization of how gene synthesis corporations should go about their businesses in terms of best practices. In the United States, you have the International Gene Synthesis Consortium, and in Germany, you have the International Association of Synthetic Biology, both of which have come up with best practices in the industry for how to go about the process of assessing orders, both in terms of what the order is against a database of knowledge about the genes, and a check of the client themselves as to whether they have a history of having a justifiable use for that technology. And then, of course, it deals with record keeping and how and whom to contact if there are suspicions. So there are international efforts, and I would very much urge the Commission in its work to maintain an international perspective and outreach to other international efforts.
We'll take that as a welcome suggestion and an occasion to thank the panelists again, and we're going to take a lunch break and reconvene at 1:45. Thank you, Artie, Ashley, and David, very, very much.